Good afternoon, Integrated 1 students. Another lesson to you coming from Miss Thompson's online learning platform. I'm really starting to miss you guys, and I'm really getting tired of talking to a computer screen. But this is lesson 5.7. It's the last lesson in chapter 5 and the unit on systems of equations. And this one involves graphing a system of linear inequalities. So in 5.6, we graphed one linear inequality. Now we're going to be graphing systems of them, which means more than one. So we're going to start first with example number 1 from page 256 in the textbook. You can follow along in the textbooks if you want. And we're looking at the system y is less than 2x and y is greater than or equal to x plus 1. We're being asked, is the point 3, 5 a solution to both systems? So we've done this enough times before. The very first thing you should think of is, we're trying to figure out if it's a solution. We have to plug that point into both equations. So again, the first point is the x, the second point is the y. And so here we have 5 is less than 2 times 3. And here we would have 5 is greater than or equal to 3 plus 1. So 2 times 3 is 6. So is 5 less than 6? Yep, yes it is. Is 5 greater than or equal to 3 plus 1, which is 4? 5 is greater than or equal to 4. It's greater than. So 3, 5 would be a solution to the system. So what exactly does that mean? We figured out that on the last, when we just graphed one inequality, that a solution meant that it was found in the shaded portion of the graph. What does it mean if we have a system of equations? So let's kind of evaluate this a little bit. So we're going to graph both of these equations. Remember, we're in y equals mx plus b form. So we have this imaginary plus 0 that tells us that our y-intercept is at 0. We have a slope of 2, so up 2 over 1, up 2 over 1, or down 2, back 1, down 2, back 1. So we have this line that looks something like this. Oh, but I messed up because we don't want it just to be less than or equal to. We want it just less than. So I need a dashed line here. So do my cool little dash, 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 dash line. Now we need to figure out which side to shade. Now notice 0 is on the line. We don't want to pick the origin for this. We want to pick a different point. So I'm guessing if y is less than, that maybe if I take this point of 1, 0, that would be in the solution. So 0 is less than 2 times 1, which means 0 is less than 2. That's true. So we're going to shade this side of the line. Okay. Now, we've graphed the first one, but this is a system. So we actually need to graph a second line. So let's pick another color here. Whoops, where'd it go? Nope, I'm still on red. Okay, why is that? Oh, there we go. All right, so now we're going to graph the second one in a different color. So my y-intercept is plus 1. I have a imaginary 1 in front of the x, so that gives me a slope of 1, up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, down 1, back 1. So essentially, and I want a solid line. So didn't quite get there. The joys of graphing with a stylus on a screen. So that's about what our line is. Now again, we need to figure out which side do we shade. So I'm going to pick the point 0, 0 because that makes sense for this one. Is 0 greater than or equal to 0 plus 1, which would be 1? 1 is not less than 0, so I have to shade the top side of the line, which is this side up here. So what actually becomes our solution? I'm going to pick another color. It's going to be this ugly green because it's right there. Our solution is where these two shaded areas overlap. So I've got a dashed line on that side. I've got a solid line on this side. And then I have everything that's in between there. So if we go back to the point that we were trying to determine if it was a solution, which was 3, 5, we can look at where is 3, 5 on our graph. It's right about here. Let me turn that black so that it stands out a little better. So we've got 3, 5, which is like right there. And so you can tell it's clearly in that green area where the two parts of the graph overlap. Right, so we go to part B, or the second one, and the second point in that example, negative 2, 0. Again, plug in 0 for the y, negative 2 for the x. So 2 times negative 2 is negative 4. Is 0 less than negative 4? It's not, because negative 4 is right here. 0 is on this side. 0 is actually bigger than negative 4. So no, negative 2, 0 is not one of the solutions. And we can plug that in here and confirm it as well here. So is 0 bigger than negative 1? It works there, but it has to work in both in order for it to be a solution. So negative 2, 0, if we go back to our graph, negative 2, 0 is like right here. And if you notice, that is not in that green part where our two shaded areas overlapped. So it would not be part of the solution set. So let's look at monitoring progress problems now, number 1 and 2 on the bottom of page 256. So this will give you a chance to practice, checking if it's a solution by substituting the point into each one of the equations. So go ahead and pause right now and take a moment and do those 2 problems. All right, I hope you actually took the time to pause and do the problems. And if we look at the solutions, number 1, you should have found was not a solution. So it wasn't in the overlapping area of the graph. But number 2 was a solution. So 1, 4 was a solution. So we can move on now to a couple special examples that I just want to touch before we move on. So example number 2 is only asking you to graph the inequality, and I just noticed there's a typo on this one. That should be equal to. So a reminder that when we are graphing y is equal to 3, that's everywhere where the y value is 3. So when we're graphing y is greater than less than or equal to 3, This is going to be a solid line because we're talking equal to. And then the y's less than are this part of the graph. And then we have y is greater than x plus 2. So I'm going to switch colors. I shouldn't have done that one in black. It's going to be hard to see. So then we have y-intercept of 2. Again, imaginary 1 here. So we go up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1. Then we this line, oh, that's like a really bad line. Like ignore it from about everything after that. And we want greater than x plus 2. So let's check 0. Is 0 greater than 0 plus 2? No. So the origin is not part of the solution. So we're talking this side. And oh, I messed up. And that line is equal to, and I need a dashed line that is only greater than, so gives me a chance to fix that ugly line. And so the space that is our solution is this area in the middle. I need like a pretty yellow. Oh, that's good yellow. Nice bright yellow to stand out. There we go. And so our solution is this line all the way over here, the dashed part of this line, and then everything that's in the middle. So the solution is just this part that's in yellow. Okay. Now, sometimes when you're graphing them, they do this thing where they kind of overlap and you get this little like piece of the pie, is what I call it. That's the solution set. But we can get like other situations like what we get here in this example. So great opportunity to use the ax plus by equals c part. So if I put, let's change back to another color. If I put 0 in for the y, 2x equals negative 1. So x is going to be less than negative 1/2. So my x-intercept is 1. Oops. X-intercept is negative 1/2. That's going to be right here. And then put 0 in for the x. Y is negative 1. So dashed line. This is going to be one line. And again, is 0, 0 part of the solution? Is 0 less than negative 1? No, it's not. So I want this side of the line. Then let's change colors again. I don't like that green, it's ugly. And we'll do the 2x plus y is greater than 3. So again, put 0 in for y. I get 2x is greater than 3. Divide by 2. So I get x is 3/2. So 1, 2, 3 halves would be right about there. And then if I put 0 in for x and I get y, y is 3. So, and it's again a dashed line. So it might not be totally obvious how I've drawn it here. Okay, is 0, 0 part of the solution? So is 0 plus 0 greater than 3? No, it's not. So we want this side of that graph. And you'll hopefully notice it's not the best representation of these, but you'll notice that those seem to be parallel lines. And we're talking about the area outside of the parallel lines. There is no point that's in both of those areas, the black and the blue. So this is where we would have what we call no solution. Or, as I've taught you, the empty set. There is no point that satisfies both of those conditions. So this one would be no solution. All right, so once again, let's look at the monitoring progress problems on the bottom of page 257. Stop this video and take a moment to do numbers 3, 4, and 5. All right, I hope you actually took the time to stop the video and do the problems yourself. I graphed these on Desmos, and you'll notice that number 3 is one of the ones that we would say has no solution. Number 4, the solution is the dashed lines here on both sides, and then it's everything in here on this like darker purple part. And then on number 5, again, dashed lines, and then it's all of this purple part. That's the solution. So you should have gotten something similar to that. Now, I know that Desmos makes it very easy to check your answers. And at this point, it really can't stop you from using that. I've taught you how to use it for a purpose because it is very useful and it is a way to catch mistakes. But it would behoove you to first graph these by hand and make sure that your graphing linear equation skills are strong. If you depend too much on Desmos, next year when you're in integrated 2 and you have to graph something by hand, you're not going to have a clue what to do because you use that crutch of Desmos too much. You should graph it by hand, and then you should check it with Desmos to make sure that you did it correctly. There's nothing that I can do to stop you from doing that on the test, but I'm just saying that eventually you might get away with it now, but it will bite you in the butt and you won't be able to use Desmos on the state test or a test to qualify for a running start, or maybe the AP calculus test, things like that. So you really want to make sure that you know how to graph the lines and shade them and check them and stuff on your own, and not get too dependent on Desmos, because when distance learning is over, it will be a tool, but it won't be a tool that you have access to during assessments. So your next step is to go on to the journal practice problems on page 155 and 156, problems 1 through 12. Like I've said, the PDF is on Google Classroom. If you don't have a way to print them, do your best on notebook paper. You can, if you have, limited access to a printer, even just printing off some graph paper is really helpful for these sections. So if you need anything, you know where to find me, and I'll be glad to help you by scheduling a Google Meet. And I, look forward to seeing your bright, shiny, faces in person next year in the fall. So have a great day, and I look forward to seeing you soon.